Hello, everybody. Yeah, this is my second time in Bogota. Last time I was here was to attend to Senior Time Festival. I think you all know by the end of March. Yeah, 21 Pilots was there. Billie Eilish was there as well. Yeah, I was very lucky to be here, and this time I hope to give something to you because you have given a lot of things to me. Actually, I still have my Transmillennium card here. Okay, so my name is Cristhian Motoche. I am a software developer at Stack Builders. I've been working there for over 6 years. Actually, I started my internship there, and since I started working there, I've been learning about Haskell, Elm, TypeScript, so a lot about typing and functional programming. And every time that I have to move on to a new language or a new stack, I always try to look for those features into those languages because I noticed they really bring a lot of things to my a lot of value to my code base. And I am from Ecuador, yeah, just around. Yeah, we are neighbors. And okay, let's get started. So we all know that Python is a dynamic and unstructured type language. What does that mean? It's dynamic because we don't have to specify the type beforehand. The type of a variable or an argument of a function is going to be given at runtime. Yeah, so in this case here, the type of these two things, of these two variables, are going to be given at runtime. Yeah, and I'm emphasizing on the word runtime here. And it is strong because Python is not going to do something crazy unless you explicitly say so. Yeah, so we try to operate or do things between two types that are not the same, and there isn't an operation that is clear or explicit between them, we're going to get an exception. We're going to get a type error exception. In this case, it says that we cannot add a string with an integer. Yeah, we will have to do some kind of explicit operation, like some kind of casting, or if we're using magic methods, override them, so that somehow we have to explicitly say how two types are going to interact between each other. So Python does care about types, yeah, but all of this happens at runtime. Yeah, we have to execute the code in order to get this type of exceptions or errors. What if there is a way to get that before we actually execute the code? Yeah, and that is where type hints come in place. Yeah, and everything related to typing started back in 2014. Yeah, it was defined in the PEP 44. If you don't know, PEP is Python Enhancement Proposal, and it was proposed by the founder of Python, Guido Rosen. And ever since, although it's almost 9 years ago, there have been many improvements in the type system. Yeah, like packaging type information, type literals, and many more things. And there are many more proposals, and you can see all of them in the typing topic in the python.org site. So what are my goals for this presentation? First, to review or introduce type hints to you, in case you aren't familiar with that. Also, we're going to see how to work with them. And then I will give you some tips, some libraries that you may find useful if you decide to start working with type hints. So let's get started. Here we have a function that is called format number, and it takes a code and a number and returns a string. But we could misuse it, like in the case you have here, where we are calling format number with the string 57 and then a number. And when we execute this, it's going to work. It's going to return something, but we know that the return type of this is going to be wrong. Because we're going to have an extra plus there. So how could we avoid this kind of misuse? Well, we can use type hints for that, and this is the syntax. If we're defining a function, the syntax is going to be the following: the name of the argument, colon, and then the type. Yeah, and for the return type, it's going to be this arrow here, kind of like arrow, the minus, and the greater than, and then the type. Yeah. So now if we do something like this and we have a type checker, the type checker is going to say, hey, this isn't compatible with that. You have to give me the right types, otherwise I think this is going to be an error. We have to give the right type so that the type checker is happy and we can move on. And I mentioned type checker because there are many options in the market. So you have, I think these two options which I've used, I noticed they have good documentation, they are open source, they also have a playground so that you can go online and start creating some type hints here and there, and you're gonna get some good nice results. I think the main difference is the community that supports those tools, and also Pyrite is written in TypeScript, and also Py comes with an static analysis tool that you perhaps could use it if you need to. But yeah, you have some options for type checking. And now coming back to the types, we have all of the built-in types that we have in Python, like ints, floats, boolean, strings, bytes, and so on. Also, if you are using Python 3.9 or earlier or newer versions of Python, you can use list, set, tuple, dict that come directly in the namespace, so you don't have to do what we did before in 3.8 and earlier versions, which was to import them from the typing module. And that's a good announcement. By the way, we have to use the syntax for that. List, square brackets, and then the type of the content of the list or the content of the set or a tuple. Yep. By the way, you don't have to do this. The type checker will infer the type based on the value. So this is just like an example to introduce to you the built-in types and collections that we have. And what about our own types, our objects, the instances of our classes? We also can annotate the methods of a function. Yeah, we can define here this function that is expecting an object of the class dice, and then it does something with it. And if we misuse it, yeah, like passing a value that is not actually an instance of that class, we're going to get an error, a type error. Also, if we try to access a property that does not exist on that class, we're also going to get a type error. Yeah, everything is going to be okay if we give the right types and we access the right properties. And with that, I finished my first goal to introduce you to type hints. Now you know when it started, the basic syntax for it, and that you can use it for your own types. There are more things to talk about, and let's keep going. And let's start with type literals. Type literals, yeah, they are basically types for values. So let me explain with this example here. Here we have the class coin that has the method toss, and it returns a literal string that can be either heads or tails. Yeah, and I can also use it with functions here. So that means that this function and this method here are going to use heads or tails, and that's it. If we try to return something different, or if we try to pass something that is not heads or tails, we're going to get a type error. Yeah, and as you can see, this is very helpful to avoid typos, because typos can sometimes happen, and it would be really a pain in the neck if we, I don't know, if we execute the code and get an error later, and just to fix something, like missing an S or something. So type literals can be helpful for that. But as you can see, writing literal square brackets and every option there is also annoying. Yeah, how could we prevent that? Or what can we do in those cases? We can just type aliases, and type aliases are basically give a name to our types. So in this case, result is literal, the literal string that we were talking about. Also, we have a group count that is a tuple of int, and then we can just set in our functions, or our methods, or classes, or whatever. And of course, the type checker is going to complain if we pass a list that is not the one that we want, or if we're trying to use it with results that are not the ones about the types that we are working with. It's going to say that everything is okay if the types are okay. And let's keep going, because there are more things to talk about. But okay, now how can types help me even more? Yeah, here I have an example. I have this function, this class called bingo, that it has the method roll, and it returns a bingo result. And bingo result under the hood is just a type alias for an int. What if I do this? What if I call the function call bingo with the result of rolling a dice? The type checker is not going to complain. Python is going to execute the code, but we know that that's incorrect, because we were expecting to get the result from bingo.roll, yeah, not dice.roll. So how could we prevent this? And I'm going to introduce a new concept here, and that's called a new type. And the new type is similar to a type alias, but not at the same time. Yeah, we're going to give a name to the type. Yeah, and under the hood, when we execute the code, the representation is going to be the same. And there are two main differences in which this is different from type aliases. The first one is that if we're going to define a function that returns a bingo result, the integer that is going to be returned needs to be wrapped, like you can see here, with the name of the new type. Yeah. And the second one, and the one that we should that is going to help us, is that it is not, although it is going to be an int under the hood, when we call it or when we try to use it with a function that is expecting a bingo result, like in this case, we're going to get a type error. Yeah, so as you can see here, the only way to get a bingo result is going to be through that function, and yeah, we're going to be able to get only integers from that function. So in that way, we're telling the type checker to double check the types, even though they are the same. Yeah, there are some, you can see them as annotations for types. Okay? Also, I think we saw this in the keynote, sorry, that we also have union types, and starting from Python 3.10, we can use the pipe to create new types. Like the case you can see here, I started with these two types, and I am using the pipe operator to say that a card is going to be either a card number or a card letter. Yeah, and also I can say the function draw a card is going to take a list of cards and it's going to return either a card or none. Yeah, so this is easier than writing union, which we had to do before in Python 3.9 or earlier versions, or optional. So if you haven't already upgraded to latest versions of Python, this is the time to do so. Yeah, I think there are a lot of improvements in Python that you should check on, and there are a lot of improvements in terms of typing as well. Now, I think we all like Python because of duck typing. So if we recall, duck typing is if I have an object that quacks like a duck, flaps like a duck, walks like a duck, it cannot be a chicken, it has to be a duck. Yeah. So in this case, let's see here, I have a dice and a roulette wheel, and they both have a roll method. I can define a protocol, in this case, to represent that I'm expecting, like in this function, a class, an object that has this structure, a method that has, an object that has a roll method. Yeah. So the type checker is going to be happy if I pass a dice, if I pass a roulette wheel, or any other class or object, that has the roll method. If I try to pass a coin, the type checker is going to complain, saying, hey, this class, this object doesn't have that method. And also if I try to access a property that does not exist on my protocol, I'm also going to get a type error. Yeah, so that's pretty nice. And if you like duck typing, for writing some kind of parametric code, this is a way to get even better things with type hints. Also, you like functional programming, like I do. You can use the callable type constructor to define functions like the ones that you can see here. Also, I don't know if you are using async operations in Python, you can also define callbacks that have some kind of property. They have some kind of structure, like the one that you can see here. And defining, I am expecting two functions, and each function is going to be one that takes an integer as the argument and returns none. So if I try to call this function with something that is not from that structure, we're going to get a type error. Yeah, and we don't hit the wall when we execute it. And there are many more things to talk about, like type variables, generics, final, param-spec, and also name it, tuples, name it, type dictionaries. But the time is so short, and there are many things that I want to talk about, so we will keep going. Okay, not everything in the typing module are types. We also have some helpers. I think the first helper that I'm going to talk about is really nice. Let's imagine we have this function that comes from some module that we don't own, we cannot modify, and it gets some kind of configuration, and it returns a dictionary. A dictionary from an arbitrary key and an arbitrary value. So if we try to access a value from that dictionary using an integer key, the type checker is not going to complain. If we try to use a string, the type checker, again, is not going to complain. how can we actually tell the type checker to give us some kind of error, because we know that getConfig is going to return a dictionary of string and some value? Well, we can use the cast helper that is going to change only the type of this function. Yeah, so the result of getConfig is going to be this time a dictionary of string and int. Yeah, so now if I try to access a property with an integer, I'm going to get a type error. And if I try to access with a string, I'm not going to get a type error. So that's good. Let's see. Yeah, I think I have some time to explain this this helper. And put a lot of attention here, because if you miss it, you miss it. Yeah, so here I have the function increaseBet, which takes a variable called money, which is an int, or none, and it returns, if money is none, it returns the literal string cannot play, otherwise it returns money plus 1. So it returns a money increase, which is going to be either an int, or the literal string cannot play. Now, what happens if I do this? I call increaseBet with an int in the first line that you can see there in line 11, and in the line 12 I'm calling increaseBet again, but with none. What happens if I call increaseBet with those results as well? What do you think is going to happen? Is the type checker going to complain or not? What is good? Well, guess what? The type checker is going to complain in both cases, because in both cases, money increase is the result, is the type of with money and without money. Yeah, but we know that when we call increaseBet with an integer, the return time is going to be an integer as well. We know that because we write the function, we can see that there. So how come we can actually tell the type checker to oversee those kind of scenarios, and I don't know, don't complain in these kind of cases? Well, we can overload the type annotations with the overload decorator. Everything that is highlighted at the moment is exactly the same. The only things that are going to be different are these lines, where I am overloading the type hints of the increaseBet function. I am saying this time that if increaseBet is called with none, the return type is going to be the literal string cannot play. And if I call it with an int, I'm also going to get an int. So now, if I call this function, if I call increaseBet with an int and with none, once again, in this time I'm going to get an error just in the second case, because I cannot call increaseBet with cannot play. But I can do call it if the return type is an int. Yeah, and well, my last helper, and that's something that I think we all saw during the keynote, is that if we are using pattern matching, the type checker is going to be there for us if we miss a scenario here. Here I have the function card letter, the function toValue that takes card letter and returns an integer, and clearly we see that we're missing the last case, which is the A. If we're using a type checker that like Pyrite or MyPy, they're going to complain. But if for some reason, I don't know, they don't complain, we can use assert never. And assert never is going to complain in the last case, telling us, hey, I can actually be called with the value that we're missing. So yeah, fix that, otherwise I'm going to complain here. So well, as you can see up to this point, the type checker is going to be our friend, our buddy, and we have to tell him or tell it, yeah, hey, I want you to help me to double check or oversee the types, so that if I misuse my functions, misuse the methods or classes, you're going to be there to tell me, hey, these types are wrong, so fix them, or otherwise when you execute the code, something wrong is going to happen. Okay, also we have, what happens if we have some legacy code, or we're using a module that comes from a library that is no longer maintained? Well, fortunately in the PEP 561, it started to define how we can use, or how can we define type hints for other packages, and then we can include those type those stub files, that's the right name. Those are PYI files that only have type definition, don't have any kind of implementation. Yeah, we can include them in the configuration of our type checker, and the type checker is going to give us some hints, and it's going to give us the type hints for the functions that we're going to use. So that's great for the cases that I talked to you about. And with that, I covered my second goal, which was to show you how we can work with types, how we can actually use them to give us some kind of errors in case we, in many cases. And finally, I want to give you some tips, some libraries that I think are very helpful if you're going to start using type annotations, like the bonus tracks. So first is TypeShed. If you haven't seen this repository already, it contains a lot of library stubs like the ones we were talking about. About a lot of types, with the types from a lot of libraries like PyYAML, retry request. So if you're using a library and you want to start using types, if that library is no longer maintained and you want to add the types, you can find them there. And if they are in there, well, you can just stub files and include them in your code base. The second one is monkey type. Also talking about gradual typing, or how can we start adding types incrementally. Monkey type is going to help us for legacy code. Here we have again the format number function, and I have defined that function in this specific package. And now here I am importing that function and defining some cases. I can use monkey type, which was created by Instagram, to execute that script and generate the stub or the type hints for the libraries inside that function or inside that package. So in this way you can start creating your stubs and use them in your code, and you can even apply those type hints to the legacy code that you have. So in this way you can start adding types little by little. And my last tip is about dynamic type checking. So up to this point, everything has been about how can we double check the types before we actually execute the code, right? Before runtime. But what if we want to go one step beyond and ensure that a function or a method is called just with that type? And if it's called with a different type, we want to get some kind of exception or some kind of error, so that code is never executed unless the type is the one that I explicitly mentioned there. Well, there are some options for that, like TypeGuard, Pydantic, Bird type. And from them, my favorite one is Bird type, because it's real fast, is real simple to use, and and let me show you. Once again, I have this format number function. It's helping me a lot today. And here I am importing the Bird type decorator from the Bird type module, and I am using the type hints as well. And in this case, in line 7, I'm calling format number again with a string, an integer. And this time when I execute this code with Python is going to tell me, hey, that's not correct. It's going to throw an exception before actually executing this function. It's going to tell me, hey, I was expecting a string, not this plus 17 string that you gave me. So fix it, otherwise I won't execute this code. So if you want to go beyond having a type checker that ensures that your code is okay before runtime, you can use Bird type or TypeGuard to do dynamic type checking in your code. So you ensure that something is called exactly with the types that you define here. And this is a good example also on how we can actually use the type hints annotations to do something in Python. Well, with that, we cover the last part of my goals. Thank you so much for listening to me.